You know, it doesn't just go from the lab to Walgreens. There's a lot of middle in there. And Sunil Kadam is in the middle of the middle. At Quintile's IMS Stem Cell Center, he's trying to match up the research to the regulatory climate. He's working to keep the connections open of the sort you just heard, working to the advantage of patients and researchers alike. New legislation to speed up the process is underway, and what is that going to mean for science? Well, he's about to tell us.
Good afternoon. Thank you. Wow, I mean, there's been so much great, innovative science. Very rarely do you go to a meeting where you hear scientists and patients, and you get inspired by both. So I'm truly thankful. I want to thank the organizers for putting this together in this format. I want to thank my colleagues who, with CIRM's interest in putting together the Stem Cell Center, are really motivated to help those that come to us and those that want to collaborate with the Stem Cell Center to speed innovation. That's what this is all about. So when I said to my son what I'm going to talk about, he said, regulatory is boring. So that was one strike. The second strike was that I'm from Indiana. Makes it worse. But I'm here to talk about negotiating pathways that help us speed innovation, taking advantage of the regulatory tools that are in place to build a better mousetrap, or to also get your innovations to the agency in a form that are readily accepted for review and then actually get approval. That's part of my job. And so in many ways, what I try to do is look at what is there, look at what it needs to be, and try to fill those gaps, and try to do this, not just because we all know about stem cells and how to develop that therapy, but also because with the entire community at Quintiles and their experience in running clinical studies, and their experience with late phase failures that large pharma and other companies may have, and how the regulators look at approvals, there is a strength that comes from there, from the experience, and so we can leverage all that. So it's not just the cells, but it's the CBER division that's going to approve all of these therapies. That knowledge is also significant in developing drugs on an accelerated pathway. Okay, so what I'm going to talk about here is the three pillars, really, or the three legs of the stool, are this therapeutic itself, what kind of therapy it is, what kind of cell type it is, what kind of features it has. That's the science, and you know all of that. But there is a regulatory process, and that feels like, imagine you're driving this wonderful Ferrari in front of a school zone, and the guy comes out and stops you on a cross path, and he's got this little red sign that says stop. I feel like that sometimes. And you go, but there are no kids here. And then 2 minutes later, you hear the bell, and all these kids just rush out of there. So in some ways, what I'm trying to do is figure out where the gaps are and try to prepare so that the next stages of the development can actually anticipate the next level of safety and efficacy that needs to be built into that therapy. So that's the regulatory process. And then finally, this morning you already heard from Jennifer about payers and what payers want. I won't go into that. But to talk a little bit about the cell therapeutic itself. If you look at this sort of schematic over here, really, you have molecular complexity on one side and you've got specificity on the other side. And as drugs have evolved, they have gone from small molecules to large molecules to vaccines and tissues, cells now. They have increased in level of complexity. So the regulation has not caught up yet to that complexity. So how do you, it was easy when you were dealing with small molecules. You could sort of say, okay, you have to understand the PK, you want to understand half-life, and then if something goes wrong, you stop taking the drug. Great, you kind of understand what that will do. That could at least stop any safety issues. Large molecules become much more specific. So even though there isn't a very large variety of sort of side effects, there are still quite a few side effects with that. But then when you come to cells, you may know the PK, you may know a lot about the dose, but the cells, after you treat, they don't stop growing. They actually grow. So that brings into it a new level of complexity. How do you anticipate safety when something is not finite and it actually starts growing? How do you develop those kinds of medicines, and how do you anticipate safety? Because at the end of it all, it is all about, approval is all about risk benefit. So that is where we're headed. But the one thing I want to talk about is there is a really bright future in here too. In addition to us getting better and better about developing these cell therapies and putting in all of the safeguards and understanding the complex biology of the cell and the host and the tissue that it's going to be in, there are also new initiatives where you could take fibroblasts and then differentiate and then convert them by direct cell programming with small molecules, cocktail of small molecules, or even transcription factors, and direct the cell programming in such a way that there are no external tissue, there's no external cells to add. You can do that to fibroblasts in the organs and the disease dysfunction itself, so that you're self-renewed without having to take ex vivo treatment. And that may be the way this whole technology, once we understand better, eventually develop, and that's when it becomes a much more manageable way of doing treatments that are directed to your own stem cells. So think about this evolution. This is where we're going, something that has greater benefit with fewer side effects. So now to talk a little bit about the regulatory pathway. On the top, I have what is the traditional pathway. You know, you file an IND or an ID, a device exemption if it comes with a device. You go through the standard phase 1, phase 2, phase 3, and at some point you have a review and a period there and an approval. What the agency is providing, and a lot of this is because of investigators and because of people who are patients and other people who are anxious to want to get these treatments, are several ways in which you could fast track parts of the process. And you would wonder, why do you need so many different ways? It's because there are different therapies, and then they need different ways of fast tracking it. So for example, if you have a therapy that promises on very early, that there are surrogate markers that you can use to understand whether you have achieved an effect, PD markers, or other ways that are predictive of what would be a distal endpoint. Then you could go with an accelerated path, and then you get that designation, and you get some additional interaction with the agency, and so you can move faster. Fast track is another one of those types of programs as well that the agency has, but it does not rely on surrogate markers. Breakthrough is more recent, since by maybe 2.5 years ago. Breakthrough is where there is initial clinical data that suggests that you are going to have an effect, and the size of that effect is going to be significantly better than any standard of care or anything that you've previously seen for that as intervention for that disease. So that has become so popular now that the agency, even in the last 2 years, has had over 230 applications for for breakthrough designation. And they have granted quite a few, and there are now drugs that have been approved because of that designation. But it needs some level of clinical data and some effect size that the FDA and the community at large feels is significant improvement. Priority is way sort of towards the end here in the review period, but you can accelerate it if you have one of those priority vouchers, so to speak. And more recently, just for cell therapies, okay, there is as part of the 21st Century Cures Act, there is a designation that's called regenerative advanced therapy, or regenerative medicine advanced therapy, depending upon how you, depending on where you look. In the regulation, it just says regenerative advanced therapy. And even in the last, since this has happened in the last 3 months, there's already one of the products, cell product that the agency has assigned a regenerative advanced therapy, and that's in the public domain. So there are ways the agencies making tools to accelerate. There are ways to use them. What I'm here to tell you is it's better to understand all of these ways that are available to you, and then to design your study and your program in such a way as to maximize the advantage that each of those provides. And what do I mean by that? If you have if you're looking for accelerated therapy, but you have no surrogate markers in your clinical study, or in your non-clinical studies that you could sort of speak to, then you can't go for that. If you're doing breakthrough and you're not carefully understanding what or rather studying what the side effect would be in the normal population for efficacy, and then you kind of come up with, say, 30% improvement, but that 30% improvement could be very, very significant. But if you don't have those baselines, you don't have a way to justify that, then you can't take advantage of that. Okay? And the same thing with some of the other ones. If you're not prepared in your clinical design or in your clinical development program to take advantage of these tools, then they don't work. And there are similar tools on the European side with accelerated approval and the conditional approval, which is slightly different because the FDA doesn't have that path. And then there is all the way to PMDA in Japan, where there is actually conditional approval, where with a limited term of authorization up to 7 years. And that is where this little arrow comes in, is that health authorities are facilitating the innovation using a risk-based approach. On the one side, you have a lot of tools with the FDA. On the other side, in Japan, you can actually get registry approval for a short period of time with promising clinical data earlier from phase 2, and then you get to produce more data to extend that approval, and finally you get a full approval. So different regions are putting in place different acceleration tools, and depending upon where you want to go, where the disease state is, how you want to develop your clinical program, you need to be ready to take advantage of that. So this is sort of my final slide over here. You want to start with an end in mind. You want to know what you want to achieve by what time, okay? And with funded programs, you have certain milestones. As Randy pointed out, you want to be able to reach certain milestones in certain time. So you better understand which direction you are going. Otherwise, you'll be doing experiments and not getting results for clinical development. So understand where you're going first. Consider what the regional regulatory requirements are. Unlike small and large molecule, there are no common guidelines for cell therapy between regions. So you really need to understand what the regional variations are in getting approval. and then optimize the regulatory clinical development path early. You better know initially what hurdles you might have to face for CMC, for non-clinical studies, for clinical studies, how many studies, what endpoints, and how will the agency look at your claim for efficacy and benefit over risk, okay? Because most of these are rare diseases, and so a lot is not known about what the baseline characteristics would be if the patient was left untreated. Those are all things you need to understand very early. And this is one I can't stress enough, is understand what a target product profile is, TPP, and keep a focus on target product profile, because that is what the agency says. At the end of the day, that is what a label is. So if you don't know what a label is, it's like you're writing, but you don't know what chapters in the actual book looks like. You're just writing randomly. And so understanding target profile is very critical. And the last thing here is make sure these are rare diseases. Most of the time they're patients in significant need with serious unmet need. Make each patient count. Whoops. Make each patient count towards registration. Don't waste any patients. Okay? And with that, the last one is here. This is what we're trying to do. We're trying to convert ideas into medicines. We're trying to get the strategy together, startup and execution, and finally get some registration under our belt. Okay? Thank you very much.